This, right?
Yeah.
Okay, so now to find the inverse function of that, this is the challenge. Now normally what we would do is we would say something like y equals 50 over 1 plus 1.1 raised to the negative x. And then what's the next step when we find the inverse function of something?
Replace
Yeah, you gotta throw that.
Yeah, we gotta flip-flop the x and the y, right? So am I doing good so far?
And then y equals stuff.
Sure.
So here's the, yeah, so we gotta, is there an easier way to do that? Is there an easier way to do that? Can you guys think of an easier way to do that?
No.
Okay, so what we're gonna do,
Let's just not have to do this problem.
well, I'm trying to think of the easiest way. What you could do is, if you guys don't realize this, but you could probably change your function around like this by cross multiplying. You can do the old switcheroo. You can do that with proportions. And
Wouldn't it be opposite? Because wouldn't you go y over 1? So it'd be y1 plus 1.1 to the negative x? Or no?
what are you saying?
Like, wouldn't it, you put y over 1, not 1 over y? So it wouldn't be 50 over y?
No, this is true. You'd have 50 on one side, so you'd have 50 equals y times this stuff, then you divide both sides by y.
Well, you can't just skip those steps.
Yeah, you can. We're wizards now. All right, so now here's the thing. This is, we can actually, if we take the log of this, we want to get this x. This is what it's bad about this problem. What's bad about this problem is we have this x way up here as a power of 1.1. So what I want to do is I'm going to subtract 1 from both sides, and I get 50 over y minus 1. And to pull that out, I need to take the log, because the log property will let me take it out. But if I choose the same base, I could cancel out the base as well. In other words, if I take the log base 1.1 of 1.1 to the negative x, and remember, whatever I do on one side, I have to do to the other, I'm going to get all this stuff here. And we'll deal with that in a second. So that's easy. So now what I could do is I could toss this to the front, and then remember this stuff right here is going to equal 1, right? You guys remember that? When the base is equal to this, it's always going to equal 1. So I really have negative x times 1 is equal to log base 1.1 of 50 over y minus 1. And then I suppose what I could do is multiply everything by negative 1, and I get x is equal to log base 1 of 1 50, all this stuff. And so that's still the same equation that we started with, right?
How do you get x positive?
Now, we're trying to find the inverse. And in order to find the inverse, I have to swap the x and y. So I did all that work because it'll be easier for me to swap the x and y. So if I say y is equal to log of 1.1, 50 over, what do I put here now?
X.
X.
That's 1.
And because I did it that way, now I don't even have to worry about solving for y. I've already done that. You're welcome.
Mr. Adams?
Yes.
Is it supposed to be y equals the negative log of?
Oh, yes. You're correct. When we hit it with the negative, I forgot to put it all on both sides. You're absolutely correct.
That was easy.
That's it?
That's it.
Wait, how did you just all of a sudden?
Well, we could clean. Wait. We're not done. We could clean it up a little bit.
No.
No. We've got to clean it up, because what's another way that I could write negative 1?
Negative 1.
No, you silly gooses. I could write it as negative 50 of x. Couldn't I say this minus x over x?
Why would you
Like I
do
said, now you're
that?
confusing everyone.
No, I'm not confusing you. I'm expanding your capacity to think.
Couldn't you do like,
So now, the reason I want to do it, shh, I'm not done.
No problems, Mr.
When I do that, I could say 50 minus x all over x. Now, how would I graph that in the calculator?
just like that?
I could say minus the natural log of, well, let's just leave it like that for now.
Yeah, that's really confusing.
That's hard enough.
Why did you like that?
Well, because I could say this is the same, you know, in order to graph it in the calculator, I would have to have the negative, and then I could say the natural log of 50 minus x over x all over the natural log of 1.1.
That was simplifying it?
That's simplifying it.
Really?
You're welcome.
The first one made more sense than that.